So in the last class, we discussed about the HCF and LCM using listing method. How do we find the LCM and HCF of two given numbers using listing method? And we also saw a limitation of that method. It was that when we are dealing with larger numbers, so the listing method, we have to list out all the factors, all multiples of that number. So it becomes very time consuming and tedious at the same time. Right? So we need an alternate approach that is way easier and can handle large numbers as well. This is where the prime factorization methods comes into picture, right? And to understand this prime factorization method, we must know how to build factor trees. So if you have not studied that topic, you can just go over that video and then come back to this. Okay. So this prime factorization method, since we already know the factor tree method, we'll just look into examples and then see how we can apply this prime factorization method to find the HCF and LCM of two given numbers. Right. So the first example says find the lowest common multiple of 24 and 40. So we have given two numbers. If we use the listing approach, it will take us some time because we have to find the multiples of 24. We'll do 24 times 1, 24 times 2, 24 times 3, 24 times 4, 24 times 5 and so on. Same for 40. If we have even larger numbers, say 96 and 99, so then again the same process goes on and on. So it will take a lot of time. Right, so we'll see how we can utilize the factor tree that we studied. So first of all, factor tree is useful when we want to find the prime factors. Remember this, we are not finding all the factors, we are just finding the prime factors. We'll build the factor tree for 24, we'll build the factor tree for 40 and then use that to find the lowest common multiple. Okay, so 24, this is the starting point. Right, so this is the starting point. Then we start building factor pairs. So 2 is the smallest prime number. Right, so we'll use prime numbers to build the factor pair. Right, so 2 is the smallest prime number. What number should I multiply 2 with so that I get 24? It is 12. 2 is a prime number, so we'll stop dividing this further. 12 is not a prime number, so we'll continue. Again, start with the smallest prime number, which is 2. So 2 6 are 12. 2 is a prime number, so we stop. 6 is not a prime number, so we continue. So 2 times 3 is 6. Right, so 24 I can write as product of prime numbers as 2 times 2 times 2 times 3. We can cross check. If you multiply 2 2s are 4, 4 2s are 8, 8 3s are 24. Right? So we have done the prime factorization of 24. We'll do the same for 40. Right? Start with 40, then build factor tree using the smallest prime number, which is 2. And if you multiply this with 20, we get 40. Again, I have 20. So if I multiply this 20 with 2, or if I divide 20 with 2, I get 10. So 2 times 10 is 20. This is a prime number, so we stop. This is a prime number, not a prime number, so we continue. So 2 times 5 is 10. Both of these are prime numbers. Right? So 40, I can write this as 2 times 2 times 2 times 5. Right? We can again cross check. 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40. Now just find the common prime factors. So this is a common prime factor. This is the common prime factor. This is the common prime factor. Right? These are not common. So the rule says that if you have any common prime factor, just use that once only. Right? So this is common to both of this. So we'll write LCM is, so this is 2 times 2 times 2 times 3. This is 2 times 2 times 2 times 5. So 2 is common. Right? So we'll just write one occurrence. Then this is also common, so we'll write one occurrence. This is also common, so we'll only use one occurrence. We'll not use 2 times 2, then 2 times 2, then 2 times 2. Because this is common, we'll just use it once. Right? And then we'll write times 3 times 5 because they are not common. Now if you find the LCM, so it will be 5 threes are 15, 15 twos are 30, 30 twos are 60, 60 twos are 120. So the LCM of these two numbers will be 120. Right? You can check if you use the listing method as well, you'll get the same answer. So 24, write the multiples of 24. It is 24, 48, 72, 96, 120, and so on. 40, it will be 40, 80, 120, and so on. So 120 and 120 is the smallest common multiple, right? So it is the LCM, right? Although it may seem that here we are getting answers quickly, but when we have larger numbers, this method is more useful. When we solve previous year questions, we'll see that this method is much better when compared to the listing method. Okay. Then find the highest common factor of 48 and 120. So we need to find the HCF of 48 and 120. Again, we can use the factor tree, right? So factor tree will do it for 48 first. So 48 will start with 2. So 2 times 24 is 48. This is a prime number, so we stop. For this, we'll write 2 times 12 is 24. This is a prime number, so we stop. For this, we write 2 times 6. And for this, we write 2 times 3. Right? So the factors or the prime factors of 48 will be 2 times 2 times 2 times 2 times 3. So 1, 2, 3, 4 times 2 and 1 times 3. We are just writing the prime factor. So we have done the prime factorization of 48. Now let us look at 120. So 2 times 60. Then this is a prime number. This is not a prime number. So 2 times 30. This is a prime number. This is not a prime number. So 2 times 15. Again, this is a prime number. And this is not a prime number, so we'll write. So because with 2 it's not divisible, we'll move on to the next prime number, which is 3. So 3 times 5 is 15. Now all are primes, so we can write 120 as 2 times 2 times 2 times 3 times 5. Right? Now we just find whatever is common. So this is common, this is common, this is common, and then we have this 3 as common. Right? Nothing else in common. So if you have to write the HCF, now remember the difference between LCM and HCF. What we have discussed for LCM. Now what we have for LCM is HCF is 2 times 2 times 2 times 3. So this is the HCF. We don't have to multiply anything else for HCF. So whatever is common, we just multiply that. Right? So 2 2s are 4, 4 2s are 8, 8 3s are 24. 24 is the HCF of these two numbers. What if I had to compute the LCM? LCM would be 2 times 2 times 2 times 3. So whatever is common multiplied by whatever is not common. Right? So 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 5s are 120, 122s are 240. Right? So HCF, we have to just take whatever is common. LCM, we have to take whatever is common multiplied by whatever is not common. Right? So for all the next questions that we discussed in the previous years, from the previous years, we are going to see how this method is more superior when compared to the listing method. Okay, so in the next class, we are going to solve some previous year questions. So that is going to close the topic on LCM and HCF.